In base B, we have R equals 0.57 bar and 3R equals 1.06 bar. What is the value of R in base 10? Express your answer as a common fraction. This is an interesting problem. It tests your knowledge on knowing how to go from one number system to another number system, going from base B system to base 10 system, and also test your knowledge how you can operate with periodic fractions and the regular common fraction, how you can go from one to another. So first let's start with number systems and system base B, okay? So we don't really know what the system is. We don't know what this base B is, but at least we can say, what's the lowest value of B we can have? Okay, we know it's an integer, we know it's a positive integer, but what's the lowest number it can be? Well, to see this, look at the numbers what we have. We have 0, we have 5, we have 7, we have 1, we have 0, we have 6. What's the largest one? The largest one is 7, which means that our number system, base B, has at least numbers from 0 to 7, okay? Which means it has 8 symbols to represent numbers, right? So, and that means that B is at least 8. It can be below 8, okay? We're just going to put it here just in case later on we find something that is below 8, we can disregard it immediately because it can be below 8, okay? At least 8. The next thing you want to do, you want to figure out how to deal with these bars, what a bar means. And what bar means is a period. So if I have 0.57 bar, it means that 57 repeats itself forever, right? 57, 57, 57, and so on, okay? And the next thing we want to know, and this is true actually anyways, this 0.57 in base B is going to look like this, and base 10 is going to look like this. Whatever this 57 bar, whatever base it is, it could be represented like this. The next thing you want to do is kind of convert this 57 bar periodic fraction into a common fraction. And there is a standard procedure how to do it. What we want to do, we want to move this period 2 positions, since our period is 2 digits. We want to move it 2 positions. How we move 2 positions? We multiply by 10 to the power of 2. Okay? And we get 57.57 bar. Now notice, this procedure is the same whether it's base B or base 10 or any base, okay? If we take 0.57 bar multiplied by 10 squared, so 10 times 10, we get 57.57 bar. Now, in our case, this 0.57 bar is in base B, and 10 written here also has to be in base B. So this is not 10 in decimal system, not base 10. It's 10 in base B, okay? Everything here is base B. All right, next thing we're gonna do, well, we wanna get back to 0.57. To do this, we have to subtract 57 out of this number. And we're back to 0.57. Again, this is, everything is here is in base B, so all the numbers are in base B. All right, so, and the next thing what we want to do is say, well, we have really an equation here for 0.57 bar. This is the left side, this is the right side, okay? We can rewrite it. We know that 0.57 bar, we call it R. So it's R times 10 squared minus 57 equals R. Again, 10 is base B 10, and 57 is base B 10. It's base B 57. So we collect all R terms, then move 57 on the other side, divide, and this is what our R is. But these are now in base B. We want to convert it to base 10. How do we do this? Well, we convert 57 to base 10 and 10 in the base 10. Okay? All right. What is, first of all, 10 in the base b? Well, it's a number that goes after we exhaust all b digits, of all b symbols. We can represent numbers. Okay? So system is b because there are b symbols that represent numbers, right? Represent digits. So we start with 0, then 1, then 2, then 3, then 4, and so on, until we get b minus 1. Okay? And then, when we're done, we get a number 1, 0, and that 1, 0 number is going to represent b. Okay? So 10 in a b base is b. Okay? Now, what is 57? Well, it's again standard procedure. 57 in base b will be 5 times b to the power of 1 plus 7 times b to the power of 0. We get 5b plus 7. And this is our final formula for r via b, okay? And this is already in decimal system, base 10 system. Now, well, we don't know b. If we knew b, we would know r, but we don't know b. So we need to look at the other formula we have, right? So far, we just used the first one, but we have a second one. And let's use that. We're going to work in a similar way as before. 1.06 bar means that 06 repeats itself infinite number of times. Now, the way we're going to deal with this number, we're going to multiply again by 10 squared. We get 106.06 bar. And now, since we want to go back to where we started with 1.06 bar, we need to subtract 105. Okay? And in this case, we got back to where we started, to 3r. So we started with 3r, multiplied by 10 squared, subtracted 105, and we got 3r. Again, 10, 105, everything in b base. Okay? We need to convert it. So first, let's find 3r. We do it in the same way as before. We got this number. And now we know that 10 is b, 105 is 1 times b squared plus 0 times b to the first power plus 5 to b to the 0th power, and that is b squared plus 5. Okay? We plug it in. This is what we're going to get. Okay? Now we got three. Basically, we got two equations, this one, and two unknowns, which we can solve and find the answer. The way we're going to approach this is this is 3r, so why don't we multiply the other one by 3, and we also get 3r here, and we just equate one to another one, okay? And this is what we're going to get. In this case, this is just equation for b. If we solve it for b, we find b, then we can use it to find r. Now notice in both sides, we have b squared minus 1 in denominator. We know that b cannot be 1. It has to be greater or equal than 8. Denominator is never 0. So, well, what we do, we multiply by b squared minus 1. Okay? In this case, denominator goes away. We rearrange the terms, and we get quadratic equation. So, we need to solve this equation. There are multiple ways to do it. One way is just to use the formula. But here I want to kind of talk about the different way of doing it. Notice that this quadratic equation has b squared with coefficient of 1. This is something called monic polynomial. And for monic polynomial, this intercept minus 16 represents the product of the roots of this polynomial. Okay? So if I have looking for two roots, in general quadratic equation give me two roots. B1 and B2, it should be minus 16. We are looking for integer B. So obviously, okay. And the way we can look at it and say, well, if I'm looking for two integers, how can I get minus 16? Well, I need to factor minus 16 into two terms. So I can get 1 and 16. 1 and minus 16. I can get minus 1 and 16. I can get 2 and minus 8. I can get minus 2 and 8. I can get 4 and minus 4. Those are really the only options I have. And I mean, we can quickly try some of them. So let's try 1. If you try 1 and minus 16 we're looking at. Let's plug 1, and you can quickly see that that is not a solution. But if you plug minus 1, you quickly find it is a solution. So really the solutions of this equation is minus 1 and 16. Just if you want to make sure that you got it correctly, you want to also plug 16 in this equation and see that you got the right answer. Now we have minus 1 and 16. Obviously minus 1 cannot be b. b have to be greater or equal than 8. So 16 is fine for this. So we found our b, it's 16. So base 16 is also called hexadecimal. And once we know b, we can plug b in this equation and find r, right? And r will be 29/85 in base 10 numbers.